So just a quick hello to people that have already joined. Thanks for tuning in. So we're going to be starting the presentation in about 2 minutes time. So when it is 10 o'clock on the dot, I like to start. Today's presentation will be about the 25-year sprinkler inspection. All right, good morning and thanks for joining me. My name's Andy. I'm from Project Fire Products Limited. Today's presentation is going to be about the 25-year sprinkler inspection. In previous weeks, we've talked through the whole of the sprinkler servicing and maintenance routine. We've looked at what is required every week, every month, every quarter, every 6 months, every year, every 3 years, 5 years, 10 years, and now it's the last kind of bit about sprinkler servicing and maintenance, which is a 25-year sprinkler inspection. If you want to find out more about what happens more regularly with sprinkler systems, then you can look at episodes 23 and 24 of Sprinkler Talk. I realised this the other day when I was kind of putting this together. This, of course, is episode 25, talking about the 25-year sprinkler inspection. Just needed it to be the 25th of the month, and then we'll have a kind of full set of 25s. So this is only like a couple of pages really of the whole sprinkler code that I want to talk about, but this is a topic which is still, I don't know, kind of mysterious, I think, to a lot of people. A lot of people kind of don't even know that this test is here, it exists, and there's a lot of confusion, I think, to do with whether this test is mandatory or not, and whether at what point this test needs to be carried out. I mean, 25 years sounds pretty easy, doesn't it, in terms of, well, when the sprinkler system is 25 years old. Agreed. But if you want to get too technical about it, is it from the point of commissioning? Is it from the point of handover? Is it from the point of design? When the building changes hands, again, we need to just keep track of this. Talked about this in the last episode as well, that if the whole building is sold, then the new owner needs to kind of understand that the sprinklers are already, let's say 12 years old. So bear that in mind. But the new owner, again, sprinklers are not going to be at the top of the list of things for them to think about, I would imagine. So again, this test often gets ignored. It's up to the sprinkler servicing team as well to kind of keep a track on this and ask the questions. You say, well, how old is the building? How old is the sprinkler system? The sprinkler system, I guess, doesn't have to be as old as the building. It might have been retrofitted at a later date. But the point is that there is a 25-year inspection, and here is what it's all about. So we're going to start off with a familiar slide just talking about code standards. Again, this is based on UK sprinkler codes. Again, it's not the case that in the UK we've got this strange idea of a longer term inspection. This is commonplace in more international codes such as the NFPA, but obviously I'm talking about the UK sprinkler codes, i.e. BSEN 12845. Plus the technical bulletins. So this 25-year inspection is found in two places within the sprinkler codes. We have Annex K of BSEN 12845, and it also appears in TB203, which covers all of the sprinkler servicing and maintenance. So Annex K is kind of separate from, so the rest of the sprinkler testing and maintenance routine in the British Standard is found in section 20, and then the 25-year inspection is kind of tucked away and it's in a separate annex called Annex K. Now, Annex K is labelled as informative. So, again, I'm not an expert on these kind of terms, etc., but I'm fairly confident that informative means that it is for information, i.e. it is not mandatory to do Annex K. It is giving you some information saying, you know, this is probably a good idea, this is something for consideration, but it's because it's informative rather than, what's the opposite of that? Is it normative? Find one. Yeah, the opposite of informative is normative, and that normative means you have to do it, whereas informative, say, is for information. TB203 doesn't make that kind of stipulation, and you can see as we go through that the language that they use is slightly different, using the words kind of shall and must. So as far as technical bulletins are concerned, this 25-year inspection is mandatory. You know, it has to be done. So I'm going to be following. Okay. So yeah, we're going to go through what the technical bulletin says, TB203, and then we're going to compare the differences towards the end. So this is what it says in TB203.3.8. Says after 25 years, and this is important, or sooner if considered necessary by system condition, or by system condition. Or condition. So replaces BSEN Annex K. So again, the technical bulletin is making clear that this is overruling what Annex K says. And you know, that's important, that 25 years is a maximum time. If or sooner if considered necessary. Why would it be considered necessary? I guess because you're seeing corrosion, you're seeing maybe pinhole leaks, you're concerned about the condition of the sprinkler heads for whatever reason. Maybe one has triggered, you know, in a non-fire situation. Maybe it's kind of malfunctioned or something. Maybe when you open a drain valve, you're getting a lot of kind of mud and silt and stones kind of coming through. And therefore, you know, if you've got concerns about the condition of the sprinkler system, then of course you can bring this 25-year inspection forward and do it sooner. This next line there is getting quite interesting, isn't it? Activities shall be undertaken. Okay, so got to do it. All defects detected which might adversely affect the performance of the sprinkler systems shall be eliminated. So, you know, that's easier said than done, but it is, you know, a nice statement that basically says, if whatever you find that ain't right, put it right, and yeah, eliminate anything which might adversely affect the performance of the sprinkler systems. Now, as I say, you know, that's easier said than done, and for me, it's a question of where to draw the line. So, for example, sprinkler pipework. Sprinkler pipework will work best when it's shiny and new. So when the pipework is new, nice and smooth, then it's going to be at its best because the frictional losses are going to be smaller. Okay, so as the pipes get older, the pipe is going to corrode and it's going to get rougher essentially, which is going to slow the water down. So does this statement mean that all pipework has to be replaced to make it shiny and new again? No, I would say it doesn't. But as I say, that's where, you know, we've got this kind of catch-all statement, which so it may not be suitable in all cases. So yeah, requirements listed as considered a minimum, which again is an important thing to point out. Insurer and AHJ consulted if there's any deviation. So again, it's not saying that you can't do something a little bit different to what's specified in TB203, but if you do, then you'd need to kind of consult other interested parties to see whether they agree with this deviation. So looking at a bit more detail then, what does it say? What do you have to actually do as part of the 25-year inspection? First of all, flush system by running water from remote end of distribution pipe until it runs clear. So we're going to be doing some flushing through the pipework. So the sprinkler system will be connected to a water supply. So it might be a water storage tank. It might be running off the town's mains. It may be running off something else. But the first thing here is to bring that kind of fresh water through the pipework and then discharge it at the other end until it runs clear. And again, I would suggest that until it runs clear, you'll be waiting a very long time for that water to run clear. For me, it should, in reality, we're saying until it's clear-ish, i.e. it's not too bad. It's going to be a lot better than what it was when you started to discharge the water. The next thing is an important one. We're going to take a sample of sprinkler heads. And we are actually going to do some testing and inspections on those sprinkler heads. How many you take will depend on how many sprinkler heads you've actually got. And there's a nice table, table TB203.T1, which tells you how many sprinkler heads are to be inspected. And as I said, that is based on the total number of heads that you've got, all the way up so it goes from 20 to 100. So if you've got a small sprinkler system, you'll be doing 20 heads. If you've got a very large sprinkler system, it'll be up to 100 heads. And I guess you might be wondering, well, how are we going to remove these sprinkler heads? So again, that will depend on the type of building that you've got and how you want to kind of conduct these kind of tests. So if you're an industrial building, which is, again, kind of the way the technical bulletins are written, they're often written from an industrial, a commercial point of view. So if you've got a warehouse, for example, you can decide, right, we're going to turn off all the sprinklers to this warehouse for 2 weeks. We're going to drain it all down, and we're going to do this 25-year inspection, thoroughly. We're going to take our time over it. We're going to do a good job, and then we're going to turn it all back on again when we're finished. With other buildings, that may not be quite so easy. So you could turn a zone off. You could drain a zone and take the heads from there. You could use like a freezing kit to remove the heads and then put a new head in or put a plug in. So there are lots of different ways in which you can do it. But often it is going to cause some disruption. It is going to cause the sprinkler system to be either down or to be compromised for a period of time whilst those heads have been removed. So once we've removed them, we're then going to send them off to a lab, to a body to actually do those tests. I'll come on to that in a bit more later. Internal inspection of pipework for foreign bodies and evidence of corrosion. So we're really checking the pipework health when we're removing the pipe. And again, there's various different ways of doing that, which I'll come on to in a few slides' time. There's a checklist of defects. So you need to kind of work your way through those. So, for example, looking actually what you've taken out of the sprinkler system. What are these bodies? Are they greater than 5 millimeters? Are they discharged in routine water tests? Are there foreign materials? Is there evidence of microbial activity? Is there evidence of, say, this persistent pinhole leaks or nuisance activations of alarm valves? There's quite a list of these things here, and depending on how many of those you're going to tick would depend on remedial actions which would be required. Remove any debris, that's pretty obvious. So again, we're going to have a thorough flush through. We're going to probably take the pipework apart in kind of key places. And again, your sprinkler contractor, service contractor will be able to advise you on that. If you've got sort of a large pipe, which maybe turns a corner and then drops in size to a smaller pipe diameter, then that would be a good place where we're probably going to catch a lot of debris. So it might be a good idea to remove a few joints around that area and just see what kind of debris you've got in there. And as I've mentioned before, this nice statement about all defects which might affect the performance of the sprinkler system shall be eliminated. I can hear someone typing, which means everyone can hear, but I think I've managed to mute that. Cool. Okay, moving on. So let's have a few slides looking at flushing now. So this diagram here was actually created for a slightly different purpose, but I've kind of put it in here anyway. This is just showing you, that the water from the water supply coming up through the alarm valve and then opening the drains. We'd say we should be located there. They are called for as part of the codes, these drains at the end of the distribution. The water supply, and then you divert it around the alarm valve and put it actually into the test connection at the remote point, and you push the water back and then take it out from above the alarm valve. So you're kind of flushing in reverse. The idea being is because the pipework will get smaller as it goes from the alarm valve to the sprinkler heads. That's just the way it is. So if you flush in that direction, again, you're going to push debris into where the pipe reduces in size. Whereas if you flush in this way, so if you're pushing it from small bore into large bore, then you're not going to have that effect, and you're going to flush the pipes more effectively. So it doesn't actually tell you to do that in the standards, but that's a suggestion from me, and say a suggestion from my former director to do it in that direction. So the sprinkler heads themselves, I know that the FPA, the Fire Protection Association, they offer this kind of sprinkler head testing and examination. I imagine they're not the only place that will do it, but that's an example of somewhere you can send your sample sprinkler heads off to. And they will do a visual inspection. They'll check the function of the sprinkler head, so they'll actually be setting them off at 0.35 bar under the appropriate heat. They'll be checking, do they operate at the correct temperature? Do they discharge the water in the way that they were designed to? Do they function as designed? Are there any damage to the heads? They'll also look at the K factor, which again is listed on the head. Is that K factor actually still good? And they'll check all of that. And then there are various points in the Technical Bulletin 203 which will determine whether the results are a pass or a fail. So obviously, if all the tests are good, then there's no need to do any further action. The heads that you've taken out will obviously need to be replaced. You can replace them from the spares kit, but often you're not going to have enough heads in the spare kit, so you would have to replace them with new heads, generally speaking. Obviously, if the same heads are still available, to purchase, then ideal. You can put exactly like for like replacement, but often you'll find after 25 years, the heads are just not going to be available. Definitely the heads that are kind of pictured in the foreground there on the picture won't be available anymore. So you'd have to choose some that are kind of a similar performance and replace them with those. But say if you do find some concerns, then you might want to test some more heads. And it says functional tests shall be considered serious failures. In such cases, all heads in the installation representative of those which failed should be replaced. So, you've got a scale really. And if you find, serious issues with the heads that you've tested, then all the heads in the sprinkler system are going to have to be stripped out and replaced, or in the installation or in the zone. So if you can kind of pin it down to a particular location, then you wouldn't necessarily have to replace them all. But as I said, that's kind of in some ways that's a grey area. I mean, there is more information in the standard, but there'd also, I think, have to be some consultation between the various parties as to what kind of action is then required. Pipework inspection then. So we want to internally inspect the pipes for corrosion, for health, for wall thickness, for evidence of microbial activity, all those kind of things we're interested in. So how do we do that? Well, I guess the kind of the easiest in some ways, well, not the easiest, the most obvious way of doing it is to actually take some pipes out. And again, the standards will kind of point you in the direction of what exactly should be inspected. We'd like a little bit of everything really. We'd like different sizes of pipe in different locations to obviously give us a good picture of the overall pipe work in the system. It's not a good idea to take all the pipe from one location because it's not really representative of the system as a whole. So we can actually take sections of pipe away, and then of course we can actually have a look in person with our own eyes. Obviously we need to drain down first, otherwise you get very wet. But yeah, we can have a good look inside, and we can send samples off to a laboratory if we want to have a look at what we find in there and measure the wall thickness, etc. So that is an option. It obviously requires the whole thing to be drained down. It also raises questions about what you then do once you've inspected it. Do you put it back? Probably not. No, you're probably going to replace it with new pipe. And sometimes there is an issue sort of marrying up old pipe and new pipe, whether it be screwed connections or groove connections. It's often not so easy to join sort of old and new back together again. So if you don't want to do that, there's a few more pictures there of what you might be able to find within your pipe. Again, lots of kind of build-up debris and corrosion. So all those kind of cause for concern. If you didn't want to remove sections of the pipe, then you could do an inspection via a camera. So it's a bit like when you go to the hospital with cameras in various places in your body. We can do this with sprinkler pipe work as well. So we can get a camera on a long lead. We obviously need to break into the pipe at some key points and be able to get the camera in. But then we can just run that camera along the pipe work, and we can take a video, and then we can watch it back. Hours of fun to watch back the video and have a look at the internals of the pipe. This one is obviously good because we're not taking away, we're not taking whole sections of pipe away as much, and we're obviously seeing potentially we can see a longer section of pipe. We can do it in several locations, but we can get a better feel for what's going on. The downside, of course, is that we're only doing like a visual inspection. We can't kind of measure anything. We can't take samples. But what the camera will help you to do is identify sort of areas of concern, and then we can actually take a proper sample of pipe from the location that's been identified. Another method of examining the pipes is to do an ultrasound inspection. So we can do sort of scanning of the pipe without actually getting into the inside of it at all. So we can actually put these kind of ultrasound pipe scanners on the outside, and we can detect what's going on the inside. Now, I'm not a big fan of this technology, although I admit that I'm not an expert in it at all. I can understand the benefits of it. Obviously, it's you don't have to do any removing of pipe. You can very quickly cover quite a large area of pipe work and get quite a lot of data. But for me, that the technology isn't kind of good enough to really get a good picture of what's going on inside. So again, I would be tempted to use it as a first port of call to do a quick scan and use it to identify areas which will then be investigated more thoroughly. What I wouldn't want to do is run an ultrasound over it and say, yep, looks fine to me, and then move on. I would be using it to say, okay, well, what's the worst area does the ultrasound reckon? And then take that out and see what we've got. Another method of taking a pipe sample is actually using one of Project Fire's pieces of kit, which is called LiveTap. So LiveTap, wasn't designed with this idea in mind, but it's sort of a happy accident, I guess, that by installing some of these fittings, you're actually taking a pipe sample. So this diagram here is showing you how to fit a quick drain onto a sprinkler system. So I'll go through this in more detail in another presentation to kind of explain exactly what LiveTap's all about. But yeah, LiveTap is there to make additions to sprinkler systems without draining down. So it's often that you may find that a drain point would be useful in this location. There isn't one fitted. So you can actually use LiveTap to fit the drain without draining down. So the water is still in the pipe as we actually put the fitting in place. So we can, by using LiveTap, we're actually drilling into the pipe and we're actually taking a little bit of pipe away as part of the drilling process. We're actually saying we can use that sample to then send off to a laboratory to get some results. We're actually doing an internal inspection with the water remaining in the pipe. So I'm not going to go through these slides in great detail, but you can see that the drill going through, breaking through the pipe there. You're taking sort of a chunk of a pipe with you. You're then drawing that back through the valve. You're then going to close the valve, remove the drill head, and that drill head, will have a little bit of pipe attached to it. We call that a coupon, and then that can be sent off to a laboratory to get some analysis on the coupon, looking at the corrosion that we find, and importantly, the wall thickness. So again, if our sprinkler system is 25 years old and we've gone through 50% of the pipe wall, then we need to think pretty quickly about replacing the whole of the pipe work. If we find that there's 95% remaining, then yeah, it's obviously good for several more years to come. So yeah, we've gone through most of these already. Checking for internal inspection, yeah. Checklist of defects, yes. Remove any debris. System performance verified. So again, once you've done all of these inspections and you put everything all back again, then you'll be doing various tests and checks to check the system performance. So looking at flow rates, looking at pressures at various points to check everything is as designed. And then again, with this statement, doing anything required to make sure that the system is in full working order and fit for purpose. This little slide about what's the difference between Annex K and TB203. So yeah, they are quite similar, but it's the language that's used. So for example, in Annex K, it said it should be inspected, and in TB203, it says it shall be inspected. Another key difference is that Annex K calls for a hydrostatic test. It means that Annex K is encouraging the use of increasing the pressure within all of the pipe work to, I think, is it 15 bar or 18 bar or 1.5 times the maximum working pressure, something like that, to check for condition. That is not there in TB203. And also there's a little statement which basically says, yeah, we don't recommend doing that. I think the argument is if the sprinkler system has been sat at 6 bar for all of its working life, but then suddenly you put 15 bar of pressure into it, then yeah, you're going to get leaks. Doesn't actually show that there is anything wrong with it in the first place necessarily, but now you've got a whole load of problems to fix which you didn't have before. So that's kind of a key difference. Annex K calls for 1 meter length of pipe to be removed. So Annex K is sort of insisting that you remove pipe. TB203 doesn't actually insist that you remove pipe. It just says you've got to internally inspect it. So for me, that kind of opens the door to, say, running the cameras or taking pipe samples, or even, say, using the ultrasound scanners as an alternative method of internally inspecting the pipe. And again, we have a very similar statement in terms of what you need to do at the end. But again, Annex K says should, and TB203 says shall. All right, and that is that. That's the end of the presentation. Now, someone's saying that I've muted myself. Hopefully that hasn't been for too much of the presentation. Okay. Have a look what's going on. No, that's been fine. Okay, so yeah, thanks a lot for listening. It didn't go particularly smoothly today, don't it? I might re-record this for YouTube. The next week hopefully will be better. So it's going to be an extent of sprinkler protection next week. So we're going to be looking at what it says in the code standards. Again, some of you might be surprised that there is a section in the code standards about the extent of sprinkler protection. But yet there is. So you don't have to put sprinkler protection in all areas of a building. There are what's called necessary exceptions and permitted exceptions. But so we'll go through that next week. I'll tell you what the score is and all of that. So yeah, thanks a lot for listening. Hope you can join me next week. As per usual, I'll just stick on the presentation just for a few minutes to see if there's any further questions. All right, thanks a lot for listening. Bye-bye.